Hello everyone, and welcome to Stuff I Found Interesting. Today's rabbit hole is asteroid mining. I ended up finally watching Avatar: The Way of Water recently, and that brought me back to how groundbreaking the original one was on a technical front. The whole point of humans going to Pandora in the first movie was to mine for resources they couldn't find anywhere else. Humans had strip mined Earth, and there wasn't a whole lot going for the planet anymore. Clearing out the indigenous people for their lands and resources, while something humans have done throughout history, is not something we really want to do anymore. What better way to utilize all of Avatar's space technology than to mine all those asteroids in space that do not have anyone already living on them? Obviously, the humans in Avatar are quite a bit more technologically advanced than we are. What would be involved in asteroid mining, and how would we do it? Asteroid mining is the extraction of valuable materials from asteroids. These materials could include precious metals, water in the form of ice, and other valuable resources that are rare or scarce on Earth. The benefits of asteroid mining include the potential for new resources that could help sustain human society, such as water for colonization and rocket fuel for space travel. Additionally, mining asteroids may also provide insights into the formation and evolution of the solar system. We have already identified some potentially rich asteroids within the asteroid belt. The most expensive one that we have found is called Davida, which has a diameter over 200 miles. It is valued at an estimated $27 quintillion. That's 27 followed by 18 zeros. Astronomers believe that it holds platinum, gold, nickel, iron, and other precious metals. Of course, getting those resources is its own problem. To make asteroid mining a reality, significant technological leaps would be required in a number of areas, such as developing the capacity to locate and track specific asteroids, developing the ability to land and take off from an asteroid's surface, developing the technology to extract resources from an asteroid, and developing the technology to transport resources mined from an asteroid back to Earth. While we can technically achieve the landing and taking off from an asteroid utilizing what we have learned from the moon landings, we have not put any of that knowledge into practice. Of course, that does not include actually mining or the travel time between the asteroid and Earth. I believe that for asteroid mining, the first technology we will need to crack would be faster space travel. Most companies would be less likely to tolerate the risk involved with extended stays in space, as much can go wrong. Additionally, companies would need to work off of a much longer time frame before they can expect any return on their investment. There are several challenges associated with identifying asteroids that would be worthwhile to mine. They are location, size, composition, accessibility, cost, and legal. For location, the vast majority of asteroids are located in the asteroid belt between Mars and Jupiter, making them difficult to reach and study. For size, many asteroids are small and difficult to detect, especially if they are located in the outer reaches of the solar system. For composition, the composition of an asteroid can be difficult to determine from a distance, so it can be challenging to identify which asteroids contain valuable resources. For accessibility, some asteroids may be easier to reach than others, depending on their location and orbit. For example, some asteroids orbit close to Earth and may be relatively easy to access, while others may be located in the outer reaches of the solar system and may be much more difficult to reach. For cost, identifying and studying asteroids can be expensive, and the cost of mining them may be prohibitively high. Until our imaging technology becomes better than it is, some companies may not tolerate the risk involved in potentially guessing wrong on a particular asteroid. The legal and regulatory framework for asteroid mining is still being developed, and it is not yet clear who owns the resources mined from the asteroids, how they can be exploited, and how the transportation would be regulated and insured. Identifying asteroids that would be worthwhile to mine is a complex process that involves identifying asteroids that are relatively easy to reach and have the right composition to contain valuable resources. Additionally, it also requires a cost-benefit analysis of the costs of identifying, studying, and mining the asteroid versus the potential value of the resources that could be attained. Once we have found the ideal asteroid to mine, there is the issue of getting our stuff there to actually do the mining. The challenges associated with getting equipment from Earth to asteroids for mining are distance, cost, weight and volume, power and propulsion, and durability. For distance, most asteroids are located in the asteroid belt between Mars and Jupiter, and some are even located in the outer reaches of the solar system. This makes the journey from Earth to the asteroid a long and difficult one. For cost, launching equipment from Earth to an asteroid can be expensive, and the cost of mining the asteroid may be prohibitively high. For weight and volume, the equipment needed for asteroid mining is likely to be large and heavy, making it difficult to launch and transport to an asteroid. For power and propulsion, the equipment needed for asteroid mining will require a significant amount of power and propulsion to reach and maneuver around an asteroid. For durability, the equipment will need to be able to withstand the harsh conditions of space, including extreme temperatures, radiation, and micrometeoroids. Getting the yield back to Earth will also be a challenge, as the mined materials will need to be packaged, protected, and transported back to Earth. Depending on the materials mined and the amount, the transportation back to Earth Earth may require a very large spacecraft, which would need to be built, launched, and operated. Getting equipment from Earth to asteroids for mining is a complex and costly endeavor that requires significant advancements in technology and a clear understanding of the costs and benefits of trying. Some technologies and techniques that would make mining easier are autonomous systems, robotics, 3D printing, local resource utilization, advanced propulsion systems, and AI with machine learning. Developing autonomous systems that can independently locate, track, and extract resources from asteroids would significantly reduce the need for human intervention and increase the efficiency of mining operations. Developing advanced robotics technology that can withstand the harsh conditions of space, such as the extreme temperatures, radiation, and micrometeoroids, would enable more effective mining operations. Using 3D technology to produce equipment, tools, and even structures on the asteroid would help reduce the amount of equipment and materials that need to be transported from Earth. Developing the capability to extract resources such as water, minerals, and metals from the asteroid surface and process them into useful materials on the asteroid instead of transporting them back to Earth would make the process more efficient and less costly. Developing advanced propulsion systems such as nuclear propulsion or antimatter propulsion would enable faster and more cost-effective travel to and from asteroids. Using AI and machine learning technology to optimize mining operations and identify valuable resources on an asteroid would make the process more efficient and cost-effective. Overall, a combination of advanced technologies and cost-effective methods would be necessary to make asteroid mining a reality. An alternative to mining in the natural orbit of the asteroid would be to move the asteroid out of its current orbit to one that is more favorable to Earth. Doing this would be its own huge undertaking, since it would be a complex and difficult task that would likely involve several different steps, including identification, planning, propulsion, navigation, time, and cost. The asteroid would still need to be identified, and its orbit would need to be studied to determine its current location and trajectory. A detailed plan would need to be developed for how to move the asteroid, including the equipment, propulsion systems, where it should be moved to, the most efficient way to change its orbit, and how to get the asteroid to stabilize in its new orbit. To move the asteroid, a propulsion system would need to be developed and attached to the asteroid. This could include using traditional rocket engines, solar sails, or other forms of propulsion. The asteroid would need to be navigated to its new location, which would likely require a significant amount of skill and expertise so that we can get it to move to where we need it to go and stay in its relative position to Earth. The time needed to move an asteroid from its current orbit to a more favorable one will depend on the distance and size of the asteroid and the propulsion system used. It could take several years or even decades before its resources could be exploited. The cost of moving an asteroid would likely be substantial and would depend on the size of the asteroid, the distance it needs to be moved, and the technology used. This is the magic number that companies would use to determine if the particular asteroid would be worth their time. Moving an asteroid out of its current orbit to one that is more favorable to Earth's for mining would be a monumental task that will require significant advancements in technology, a clear understanding of the costs and benefits of the endeavor, and a legal and regulatory framework that addresses the issues of ownership and exploitation. While there are many new developments and technologies ongoing now that we could eventually utilize for asteroid mining, I will highlight two of them here. The first is a new announcement from NASA, which is incredible. They are partnering with DARPA to start testing a new nuclear engine for space travel to Mars. This would cut down the travel time from 9 months to a projected 45 days. This is an incredible improvement if it proves true. The reason we would want to cut down on travel time is not just to save time. We would not need to pack as many supplies, which helps logistically and lightens the overall load and helps with velocity efficiencies. The shorter travel time will also leave less time for things to go wrong, since space is dangerous. The nuclear fission engine would generate heat, which would then be transferred into a liquid propellant. This propellant would be expanded by the heat and exhausted out a nozzle to provide thrust for the spacecraft. NASA plans to use this new engine in a Mars mission in 2027. The second new development is a project led by Arizona State University that will send a probe to the asteroid Psyche, which is between Mars and Jupiter. Psyche is thought to be important because it appears to be an exposed nickel-iron core of an early planet. If Psyche is what we believe, and we can get good data from the Psyche mission, then we can learn a massive amount about our own planet, along with getting a better idea of how planets like ours are formed in the first place. The Psyche mission will be launched on October 1st, 2023, and NASA's Jet Propulsion Laboratory will be responsible for management, operations, and navigation. As we learn more about asteroids and develop faster, more efficient methods of space travel, we start getting closer and closer to answering the question of when asteroid mining will be profitable. It is obviously prohibitively expensive at the moment to try. As we get better at working in space, those costs will go down, allowing us to take further steps steps away from Earth and into the wider solar system. Please let me know if I missed anything or got anything wrong. I am by no means perfect, and I did not go to school for any of this. Also, let me know if you want me to dive deeper into any of the topics covered today, since this is really interesting to me and I would love to do so. As always, thank you for your time. No matter who you are, we all get 24 hours in a day. Thank you for spending a portion of it with me. See you next time.